Okay, so now I've switched to the 1 kilo ohm resistor, and I'll go ahead and start shining my light. I have this background of 0.17 milliamps and 0.15 volts across the resistor. Now I'm starting to shine a light on the resistor, and you can see that the voltage across the resistor in this case is about 4 volts, and the current is close to 4 milliamps. And that makes sense because it's a 1K resistor. If you take your 3.7 here milliamps, multiply it by 1,000, you get about 3.7 volts. So that tracks accordingly. And then here's the voltage across the transistor. And what we'll find is that the sum of these two is equal to the voltage across the battery. Now let's see what happens as I increase the intensity of the light shining on the transistor. Getting closer and closer. You can see that, pay attention here, we'll pay attention to both of these. The current and the voltage are both increasing as we get closer. But now what happens here is you'll see that the increase starts to slow down. And we're actually, at this point, we're pegged at about 6 volts. And you can see I'm only at D. I have quite a ways to go. If I keep on moving in closer, you can see that the voltage across the resistor and the current through it don't increase. What happens is that they've saturated. You can see that there's no significant change here. The change is actually quite small. So we're at this point now where I have all my battery voltage is dropped across the resistor, and then I only have about 1/10 of a volt across the transistor itself. Okay, that was with a 1K resistor. Next, I'm going to go to the 10K resistor.